Welcome back. In this session, I'll give you an introduction to the Serverless SQL Pool. Serverless SQL Pool is one of the many compute options available in Synapse. It's a serverless distributed query engine that you can use to query the data in your data lake using the familiar T-SQL query language. It's serverless, hence there is no infrastructure to provision or clusters to administer. As we saw earlier, when you create an Azure Synapse workspace, a serverless endpoint is automatically created. When you run queries, Azure takes care of spinning up the resources and running the query. You just pay for the data being processed. Serverless SQL Pool uses distributed query processing engine called Polaris, to which you can send to T-SQL queries to execute and process your data. Let's now take a look at the architecture. It uses the driver node, worker node architecture you generally see in distributed computing. Just that the driver here is called the control node and the worker is called the compute node. Applications where users can connect to the control node, which runs the distributed query engine, Polaris. Once the control node receives the query, it breaks that down into smaller tasks and identifies the compute nodes required to process the task. This will be things like the number of compute nodes required and the size of each of those nodes. It then assigns the tasks to the compute nodes. Once the compute nodes complete the tasks, the results are then returned back to the control node. It then returns the results back to the application or the user. In this example, the control node decided to use only 2 compute nodes for this query, so it created the 2 tasks and executed them via the appropriate compute nodes. That's the architecture of the Serverless SQL Pool. In case you are interested in understanding the Polaris query engine, here is a link for the white paper. It's an interesting read, so I would encourage you to have a look. I'll also add the link to the course material for you. Now that we understand the architecture of the Serverless SQL Pool, let's go through the key characteristics of the service. As we said earlier, it's serverless. Hence, there is no infrastructure to provision our clusters to administer. Azure takes care of everything. Similarly, Serverless SQL Pool uses a distributed query engine called Polaris. Also, the distributed query engine has built-in query execution fault tolerance, and it provides high reliability and query success rates, even for long-running queries involving large data sets. It also adds and removes the nodes as required by the query. People who have been familiar with Microsoft SQL Server would be familiar with the T-SQL. Serverless SQL Pool allows us to T-SQL syntax to query over the data lake, which is great. Integrating the connectivity via T-SQL interface then provides the ability to use business intelligence tools such as Power BI and Tableau, and also query tools such as SSMS and Azure Data Studio to connect to the Serverless SQL Pool. As we discussed, Serverless SQL Pool may use 1 or more compute nodes for executing our queries, and they could be of any size. As a consumer, we don't pay for the resources directly, so there isn't any upfront cost. The billing is based on the data being processed by the queries we've run. Its pay-per-query model, Synapse provides the tools to set cost control so you don't exceed the limits unknowingly. You can apply cost control via the user interface as well as to T-SQL. Serverless SQL Pool doesn't store any data. We use the service to read data directly from the data lake, so you can't create the normal tables within this Serverless SQL Pool. Instead, you can create external tables or views. Those point to the data in the data lake. Because we are carrying the data directly from the data lake, we can save time and resources to ingest the data and benefit from the data immediately. Via Synapse Link, we can query the data from Cosmos DB, Dataverse, and also SQL Server 2022, which is currently in preview. Serverless SQL Pool allows us to query data in Spark tables created by the Spark pools. Thanks to the metadata sharing between the services and Azure Synapse Analytics. As we said, we can query data directly from the data lake via Serverless Pool. It supports both Azure Blob Storage as well as the Azure Data Lake Storage. Of the files stored in Data Lake, there is support for only certain data formats. It supports delimited files such as CSV, TSV, pipe delimited, etc. It also supports JSON file format via the combination of CSV parser as well as JSON functions. It also supports Parquet format. For those of you not familiar, Parquet is an open-source columnar file format which is efficient when selecting a subset of columns for big data analytics. The recent addition to the supported file formats is Delta Lake. Again, Delta Lake is another open source file format. Delta Lake simply provides transactional layer to the Parquet files. Apart from these, you can read data from Cosmos DB via Synapse Link. At the time of recording, there is only support for SQL API and MongoDB API. Also, you can read data from Dataverse using Synapse Link. And as we said earlier, SQL Server 2022 support is currently in private preview as well. In summary, Serverless SQL gives us the ability to select data from any or all of these sources and combine them in a single query, which is really powerful. Let's now go through the use cases for which Serverless SQL Pool could be used. Any data project, the first step is to explore the data we brought into the data lake to see how to make sense of it. At this point, we don't know the quality of the data, the kind of information we need to perform on the data, and the amount of compute resources required to process the data. Serverless SQL Pool is an ideal candidate for this use case. In a matter of seconds, we can start to explore the data and gain insights from it. If we identify the data to be useful and required to be processed continually, then we could look at using either Spark Pool or dedicated SQL Pool. Using Serverless SQL Pool, you can create logical data warehouses on top of the data in Data Lake. You can create database objects such as external tables or views on top of the data lake, as well as from the data in Spark Tables and Cosmos DB or Dataverse. And finally, we can use the T-SQL functions to perform simple transformations on the data so that the transformed data could be consumed by BI tools as well as copied into SQL databases as required. Having said this, Serverless SQL Pool is a good candidate for logical data warehouses and data transformations, only if you don't have a specific requirement for predictable performance. This is because Serverless SQL Pool is reading data directly from the data lake, which won't have the same benefits as the dedicated SQL Pool tables, which have indexes and optimized distribution of data for retrieval, etc. Also, Azure manages the resources required to process the data in the case of Serverless SQL, unlike in dedicated SQL Pool, in which we define the size of the SQL pool ourselves. So if you needed predicted response times, you may want to consider dedicated SQL pools. Serverless SQL Pool can be used by most of your team. Data engineers can use the tool to explore the data lake and transform and prepare the data to simplify the data pipelines. Data scientists can quickly explore and reason out about the data before using it in their models. Data analysts and BI developers can directly use the data in the data lake or Spark tables in their dashboards or exploration tools of their choice. In summary, Serverless SQL Pool can be used for various use cases by most of the team. It's still evolving and it's only getting better after every release. So that's the end of this session. I hope that's given you a good introduction to Serverless SQL Pool, and I'll see you in the next session.